skipping over for the next question. Okay, number 2 here talks about the presidential election in November 2008. A local newspaper conducted a poll of residents of a medium-sized city and found that 120 out of a simple random sample of 250 men intended to vote for Barack Obama, and 132 out of a simple random sample of 240 women intended to vote for Obama. Is this a convincing evidence that there was a gender difference in Obama's support of the city? Support your conclusion with a test of significance using an alpha of 0.05. So what are we trying to say here? We are testing a null if the difference, and we could do male minus female or female minus male. Either way, it's not going to be wrong as long as you define it correctly. But I would say the proportion of male minus the proportion of female who's voting for Obama is equal to 0. That's our assumption. The alternative is we could think maybe that females are going to vote more for Obama, or we might think that males might vote more for Obama. But here it just said, is there a gender difference? So here our actual question, what we're trying to prove is if there is a difference. So this is 2 samples. This is a sampling test for proportions. So we would name this a 2 proportion z-test. Or some people call it a 2 sample z-test for proportions, excuse me. Okay, so let's check our conditions. Here we might want to define the PM and the PF to be the proportion of male and the proportion of female. Our first condition, random. The problem states that there are 2 simple random samples were taken, right here, SRS. But make sure it's in both samples. Okay, our normality condition. Remember, this is for proportions, so the normality condition for proportions is the numbers of successes and failures for male and for female all have to be greater than 10. And you don't actually have to look at the proportion. We have here 120 men, and if we do 250 minus the 120, that would be 130, would be our number of failures for men, 132 women, and subtract that from the sample size of women, and 108, the number of failures, are all greater than 10. So we can assume approximate normality, or the normality condition is checked. And then the last condition, independence. We need to check really 2 independents. We have 2 independent samples. Of men and women. And since they're randomly selected, there's no reason to believe that one would affect the other. Voters, men and women voters. And also, we can check the 10% rule for each individually. 10 times 250 we would think would be less than the population of male voters in this population, in this town. And for the females, 10 times 240. And notice these sample sizes are different, and that's okay. That'll happen a lot. And experiments or in random samples. They don't have to be the same size. 10 times 20, 240, 2,400 women is less than the population of women voters, and I should write in this town, in this medium-sized city. Okay, so we've checked our conditions, so we can proceed with our calculations. So we have found our p-hat for men is, let's see, 120 out of 250, which would give us a q-hat of 130 over 250. And our p-hat female is 132 out of 240, which would give us a q-hat female of 108 out of 240. Now, the big difference here is, don't forget, we need to find that combined proportion, meaning what would we expect it to be if there was no difference in male and female. So you take the whole sample together, 240 plus 250, and all the successes together, 120 plus 132, and that gives us our combined proportion, which is about 0.514. So our test statistic, our Z, is the difference in our statistics, 130 over 250, 120 over 250, minus, and make sure it's male minus female, 132 over 240. That's the statistic, minus the parameter, and the difference in the parameters here is 0, and that's going to generally happen on these tests, over the standard deviation of the statistic. And remember, we're going to use our pooled proportion here, which is 0.514 is our combined proportion. If we subtract from 1, we'll get 0.486 for our q-hat C, over the total number of males, 250, plus same thing, 0.514 times 0.486 over the proportion of women, 240. Now you can do this all on your calculator under two-proportion z-test as well. Okay, this standard deviation, z-score, I come out with as negative 1.55, this test statistic. So if we look at it on a graph, this is a two-tailed test, and so for it to be greater than or less than that z of 1.55 or negative 1.55, you can either use norm CDF or use the p-value on your calculator, but make sure it's doubled what you get if you push an norm CDF, which is 0.0606 or somewhere about that, and 2 times that would be 0.1212. Not a very low p-value. So, don't have much room for a conclusion, but to conclude, we would say with a p-value of 0.1212, which is greater than our alpha of 0.05, we would fail to reject the null, meaning we do not have sufficient evidence from this data to conclude that there is a difference in the proportion of males and females who supported Obama. So make sure your conclusion includes the p-value, compares it to alpha, or says whether it's small or not, significant or not, whether you reject or fail to reject the null, and make sure you talk about the proportion, the difference in proportions, which is your parameter. Always mention the parameter and the alternative in your final sentence, which in our case was we do not have sufficient evidence to conclude that there is a difference in the proportions of males and females who support Obama. Okay, last one here. Construct and interpret a 95% confidence interval for the difference in proportions of men and women who supported Obama in this city. Okay, so remember the main difference in a confidence interval. Well, first of all, we don't have to check the conditions again. We would first state we want a 95% Z interval for two proportions. We can just mention that the conditions were already checked above. And to do it, remember, for a confidence interval, we're going to first do the statistic, which in our case is 0.48. 0.48 is just your p hat male minus 0.55, and that's your p hat female here. P hat male, p hat female. Statistic plus or minus your critical value. Now your critical value is your Z star for proportions, and since this is a 95% interval, we use 1.96, but we could look that up on our table if we needed to, times the standard error. And remember here we're going to use our p hats because we don't assume that we already know what the true p is like we do in a test. So that would be 0.48 p hat male times 0.52 q hat male over the sample size 250 plus 0.55 p hat female times 0.45 p hat q hat female over its sample size 240. That would give us an interval of negative 0.158 to 0.018. Now sometimes this is harder to interpret because we're talking about a difference in two proportions. So really think about what you're saying. We are 95% confident that the interval from negative 0.158 to 0.018 captures the true difference in proportion of male and female voters who support Obama in this city. You might want to somehow say that we're talking about male minus female. So if you look at this interval, well, 0 is in that interval, so if we use that in our test, our hypothesis test, we would really come up with the same results. We would say that since 0 is in this interval, we fail to reject the null. It's not terribly unlikely that the true difference is 0 because it does fall in our interval. And if we want to interpret that level, 95% of all intervals calculated in this way would capture the true difference in proportion of men and women who supported Obama in this city.